So let's look at finding values for inverse functions from tables and graphs. Now we've had some practice with graphs already. We'll just do a little bit more, but tables is a new one. So, with our inverse functions, what we need to keep in mind is typically how our function works and how we've used functions so far in this course is when you have f of something equal to something else, then what we have inside the parentheses is our input value. It's like our x value. And then on the other side of the equation is the output value, or our y value. Now inverse functions reverse this. So what's inside the inverse function is the output for that function f. So what we'd have in here is that output, or you could think of that as the y value for that function f, and that's equal to, and then what we're solving for is an x value, so our input, or x. So it's like what we're doing with each of these, except for that last one, but each of these where we're looking for our inverse function, and where we have this value inside the parentheses, what we're really solving for is an x value. We're trying to find the x coordinate. So, it takes, after we've had so much practice and training our brain to work in one way, what this inverse function does is it reverses it, switches it around. So, where I have this inverse of g of -2, what I can think of is that this is the equivalent of looking at just my function g of x, and where is the output -2. So that's the equivalent, and I want to find the x value that goes inside my function g to make that output of -2. So I have this y value of -2, and I want to find the x value that matches up with it. So what I'm going to do is go to g of x and search for -2. So where I'm focusing my eyes is on this row right here for g of x, and I want to find -2, which is right there. And what I want is the matching x coordinate, which is +1. And that's my solution. So this notation, inverse g of -2 equals +1, is the same exact thing as writing g of +1 equals -2, where we have this x value of +1 and this y value of -2. It's just when we're using our inverse function, where we usually have our input, it's the equivalent of a y value. So our input is a y value, and we're getting out an x value because it's reversing the direction of the function. So while this is all from the same coordinate, the order just changes when we're using an inverse function. So if we're taking the inverse of +2, so what I have here is a y value for f of x. So what I'm going to do is look at my row for f of x, and I'm looking for a +2, which we have right there. And what I want is the corresponding x coordinate, which is 0. So this is exactly equal to 0. So again, just to show us that notation, this inverse function of 2 is equal to 0, but I could also write that same coordinate as f of 0 is equal to +2. Solves for the same thing, uses the same point, it's just how the notation changes. Alright, inverse function of 0. So I want to look at that row for f of x, and I want to see where's an output of 0. However, what I can see is f of x never has an output of 0 on this table. So with that one, I would say does not exist. And for this last one, we're going to layer some pieces. We're going to have our inverse function as well as some composite function work. So for simplifying the inside there, So I'm looking at my function g, and I want to see where does g have an output of 0. So I'm looking at g of x, and I see my output of 0 right there, and I want the corresponding x value, which is 0. So where I see this inverse g of 0, I can replace all of that with just 0. Now, just to kind of twist our brain around, this f of 0 is not an inverse function. So now we have to remember, how do we usually work with these inverse functions? Well, that input is an x value, and we want the output for that function. So with this one, f of 0, what we're doing is we're letting x equal 0, and we want our function output for f of x, which is 2. And that would be our final answer. So just to kind of briefly remind us how we usually use the functions, just when we have inverses, it switches order. So typically when we use our functions, we look at x first and then find the function output. When it's inverses, we're looking through the function outputs and finding x. Alright, and just some more practice with our inverse function. And sorry, there is a duplicate here, so we're going to skip that last one because it's the same as the first. Now, we could start solving these right away, or what we can do is go ahead and graph that inverse function. So reflecting over that y equals x, so that means any point that's on y equals x will stay there, and then we'll have these points come through. Now in terms of reflection, how I'm visualizing this is diagonally, so like because it takes this kind of diagonal distance across one square, for symmetry it'd be 1 over that way. Same thing up here is in a distance of 1, but diagonal across one square. And there's more of these. This also has a distance of 1, so it'd be about there, and yeah, so on and so forth. But with those points, I can go ahead and graph. I'm going to go ahead and use straight line for accuracy here. Alright, so there's my inverse function. So, inverse function of f of 4. So what I can do is just focus on this line here that we just graphed. So if my input is 4, which is out here, my function output is positive 2. So finding these points from a graph, if you've graphed your inverse function, it's just using x and y, input, output. The idea is that from our original function, we could see these same points, where 4 was the output of the function, and finding x would be positive 2. So just reversing that order, but if we have the graph itself of the inverse function, just use it. So if our input is 2, then our output is 0. Here, it's just our regular function, so if x is 0, where's my f of x? It's up at positive 2. And what you could notice is that these are actually looking the same coordinate. It's just one's the inverse and one's the regular, where if it's f of 0, so we have x of 0, y of 2. With the inverse function, x of 0, y of 2 from our original function. Inverse function of 0, so if x is 0, our inverse function's at negative 2. And then at negative 2, our inverse function is down here at negative 3. So where we've worked with these coordinates on graphs, kind of talked about like looking at the coordinates on the original graph and switching them, and we can do that. But also if you just graph the inverse function, you can grab the coordinates directly without having to worry about switching them. So sometimes it can help to have a graph first and just grab input and output values.